Hello everyone, and welcome to another algorithm video in Python. In this video, we will be learning about the binary search algorithm. Binary search is an algorithm that finds a value or element within a given list. There's only one thing that you must know about this algorithm before we move on. You must provide or use a sorted list from least to greatest. I will explain the reason for this later on in the video, but for now, let's get started. The first thing that I will do is show you a quick visual example of the binary search algorithm and how it works, which is up on my screen right now. Then I will show you how to program the binary search algorithm in Python. As you can see, there is a list of 7 elements up on my screen. They are all ordered and sorted from least, which is 10, to greatest, which is 70. The first thing that the binary search algorithm will do is find the middlemost point of the list, in this case it is 40. Then the algorithm will compare your value of what you want to find within the list with the middlemost point. So let's say that your value is 60. Let's say that you want to find 60 within this list. The algorithm will compare 40 with 60. 60 is greater than 40. So 40 and everything to the left of 40 will be eliminated and new base will be moved to 50. And this is why it is so important to have your list sorted from least to greatest. Because the computer knows that 60 is greater than 40 and everything to the left of 40 is less than 40. So there is no point of checking whether one of these elements is the value or element. And the same for vice versa. If your value was, let's say, 30, and the computer compares 30 and 40, and it knows that 30 is less than 40, it can immediately discard all of these 4 items because there's no point in checking them since they know they are all larger than your value or element. So let's continue on with the process. The computer will then compare your value 60 to 50. 60 is greater than 50. So the computer can eliminate 50 and it will change the base point to 60. Finally, the algorithm will compare 60, which is the base point, to your value, which is also 60. And it will find a match. In this way, the computer knows that 60 was your element and value, and it will return 5, which is 60's index, 0, 1, 2, 3, 4, 5, so it will return 5. And that is how the binary search algorithm works. And now we will move on to programming the binary search algorithm in Python. So here we are in our Python editor. So the first thing that I want to do is create a new function called bsearch. Bsearch is short for binary search, of course. So we'll go def bsearch, and we'll pass in 2 parameters. The list in which you want to use to search for the value or element, and the value or element itself. So we'll add the colon. Now I want to initialize 2 variables. Start index, so we'll do start underscore index, and we'll set that equal to 0, of course, and the end index, which will be equal to the length of the list, minus 1, of course. And we're subtracting 1 because this built-in function in Python starts counting lists or any object from 1, while indexes start counting from 0. So to even them and make them the same value, we want to subtract by 1. Then, I'm just going to add a comment here. Sorry, my keyboard, I need to change. Sorry, I just had to change my keyboard language there. So, we'll do a hashtag for the comment. And we want to comment find the middlemost value, because that is what we're going to do right now. So we're going to have a while loop while the start index is less than or equal to the end index, we want to initialize a new variable called midval, which is short for mid-value. We want to set it to the start index plus the end index, divided by 2, of course. Now we'll just go on some new lines. If list midval is equal to your value, we want to return midval. So what we're doing here is we're checking if your value or element that you wanted to search for within the list, if it turns out to be the middlemost point of the list, then we can just return midval and the whole algorithm is over. But that is not always the case, and it usually will not be the case. So now we want to compare the user's value with the mid value. So we'll just have a comment there. Compare the user's value with midval. So we want this to be part of the while loop, so we'll just add a tab right there. And we'll add another if statement. If value is greater than list midval. So if your value or element is greater than the middlemost point of the list, we want to set the start index equal to the midval plus 1. So to explain this code better, I'm just going to create a quick list in the Python shell of seven items. So the whole point of these two variables is so that we know what to check and what not to check. As I explained in the visual example, the computer can eliminate those 4 elements on the left because the computer knew that 60 was greater than 40. So this is the case right here. These two variables are there so that we know what to check, and we know what is obviously not the value, so we can just discard that. So whatever is in between these two variables is what we need to check. So let's say your value was 6 again. So then this would be true, and the start index would be set to midval, which is 4, plus 1, which is 5. So the start index would be set to 5, and the end index would be still set to 7. So now the algorithm knows that since the start index is equal to 5 and the end index is 7, we only need to check from 5 to 7. These 4 other elements are not your value. These 4 elements are certainly not your value, and they can be just eliminated, and these 3 elements are holding or containing your value. And also, if your value was 3, then we will add an else statement. Else end index, we want to set the end index to midval minus 1. So midval minus 1 is 3. So the start index would stay 1, and the end index would be 3. So 1 to 3 is what we need to check for your value, and we can just eliminate 4, 5, 6, and 7. So that is the whole reason for this 4 lines of code and these 2 variables. So now we're just going to go on a new line, and we want this line of code to be outside of the while loop. And this code is going to be just very simple: return none. And the reason we're doing return none outside of the while loop is if the algorithm or if the program went through this whole while loop and still got no result, it will go to return none, and it will return none. Because if the computer got no result of this, then that means that your value or element is not in the list, is not to be found in the list. So for example, if this was your list, your value would be something like 10. And the computer would run this, and it would see that your value is not in the list, and it will go to this line and run this line, and it will return none. So that is the algorithm. The only thing left to do is initialize the list and call the function, call the algorithm. So we'll just have another comment here, initialize the list, and we'll set variable list equal to 4, 2, 3, 8. Oops, sorry. We can't do that. It has to be in order from least to greatest. 2, 3, 4, 5, 6, 7. I've been stressing that fact for a long time and I forgot to do it myself. So we set the list equal to 1, 2, 3, 4, 5, 6, 7. And we will call the function by printing. And then to call the function, we have the name of the function, bsearch, and it has 2 parameters. So in parentheses, we will have the first parameter, the list, and we want to set the list parameter equal to this list. So we'll type in list, because that is the name of our list. If we should maybe name our list something else to avoid confusion, we'll call this my list, my underscore list, and we will pass in my underscore list as the list parameter. And second, we have our value, which will be, let's say, it will be 5. So now we can save our program and run it. And we have a syntax error at line 18. So I've found out the issue. We need to indent return none by 1. So it is aligned with the while. And now we can save our program and run it. And as you can see, it returns us the position of our value, which is 4. And the position of 5 in this list is of course 4, because it is returning the position of your value or element, but it's returning it as an index. And remember, indexes start counting from 0. So we'll just count 0, 1, 2, 3, 4, and the 4th index of the list is 5. Now, let's try 10. 10 is not in the list, so it should run this code, and it should return none. We'll save this and run the program, and it returns none. So there you have it, a fully working binary search algorithm program in Python. So that concludes this video on the binary search algorithm in Python. If you liked it, don't forget to leave this video a thumbs up and comment, and don't forget to subscribe to my channel as well. And I will be back soon with more content. Thank you for watching.